Okay, so we are live finally. It took me a while to do this screenshot and screen thing. It's not working here. But so, after half an hour, we can start. And I will start. So, okay, now this is my thesis. I'm writing my thesis. Latex, love it. But then, I wanted to vibe code a little bit today. Still, like related to research. So I even show what I'm doing. Why? Because why not? Basically, what I'm doing here is well, let me also do something cool experiments. Thanks. So basically, I'm just chatting with Claude and talking to it, and he come up with this amazing thing. The idea is, okay, I want to create an encoder, like a simple MLP, that basically, from the rotation of the data, it will basically encode them into like 1024 dimension, which is something I need for my research. And then it will basically um, and basically what I want to do is try to find a way to encode this information in 1024 dimension, which is better for the network, which is, oh shit, look at this pattern. I don't know what algorithm is this, but it looks so fucking nice. But and so that this thing has to be optimal, but I cannot just randomly sample points on a sphere, because I want the network to actually learn the best way, and in order to learn the best way, it needs to be able to fairly good interpolate between things. So what I get is this sphere, right? And I'm gonna do points. So basically they are already in 0 between 1. They are already bit from 0 1. 0 minus 1 and 1, yes. So we are already good to go. And then what we have to do is we need to generate like a test set and train indices, and these can be like, I don't really care as long as they are also uniformly sampled. Okay, so we can do something like this. Let's try to do this, because when I want to program like in a good way, that's what usually I do. I always like to have like the Jupyter here, and basically do whatever it is in Jupyter, and then samples. I mean, it should be len Cartesian. Exactly. And can you please show the same images as above, but color all the pixels that are in the train indices red and the one that are in the test indices in green? should. They're fairly random, which we don't like. Because, yes, we don't like it. We also want a uniform distribution on this data. Can you do a uniform distribution instead? Okay, let me see if that's what I want. Fortunately, it's very hard to understand. But yeah, I think it's more something like this. Because in this way, the model needs to kind of learn how to interpolate this data. And it will not. So the thing is, either well, the test set could be like a just random set. Yep. Okay, so we call this, instead of test, we call it this validation. So we validate on this thing. But then our real test set is something even different. Our test set is gonna be like just whether test set, yes. Test set is kind of just random values. Yeah, so we are generating just quaternion data. Yeah, it's good. Okay. Generate quaternions. Good. No, actually, we'll just quaternion data. So validation set equal yes, yes. Test set. Bro, like that's why you cannot code just vibe coding. Like this is this is like the what you should not do. Like exactly what you should not do. So please guys, don't just mindlessly vibe code. Yet. This doesn't make sense. Something like that makes more sense, I think. It does not make sense. Okay, so now we can do something similar. now just take a random, no, take 1,000 points on the surface of the sphere uniformly distributed. Let's see what I think it should be something like just NP random for 3 dimension, and that's it. Cool. Cool. Now draw the plot as before. So basically, I think I'll try to do some of these. Yes. I can accept this. That's actually amazing. Thank you for this code. So this is gonna be our test set. Thank you so much. Then test. Set test set. We want this. This we take away. Tam 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 tam. So we have number of samples, right? Let's say yes. This is, we have a number of samples here, and the number of points should be equal to the number of samples, right? And then every tenth means we are taking 1/10. So validation split. That's equal to int. I mean, of course, this is not gonna be the. It's not usual thing to do because. But I don't care. It's correct. So. And test and 1. Perfect. No, wait. No, I think this and 1 is wrong. Because I have to take 10. Validation split is 0.1 times this. Let's take this. Step equivalent points and non samples. Exactly. That's what we like. So I love this thing that the variables coming from there. Wow. Wow. Cursor. Wow. Nice. Very nice. Very, very nice. I mean, I'm no one, but who cares? I like it. I don't know who's the second person watching, but hello. How are you? Yes. So, generate quaternion data. generate translation data and something same thing. And here I don't care, we can have like a uniform distribution. Why would you generate something like this? I don't get it. The only thing, and that's why we need even to shuffle these things, I don't like, since it is a uniform distribution, we need to be careful not pairing like the first element of the first with the first element in the like heart, because otherwise there's gonna be like a bias toward this match. So we need to shuffle both of them actually. I know, because I need to do it here. Well, it's fine. Let's do it later. No. I think I want something like this. And then we do like translation, exactly. Then we well, yeah, we could just do that actually, I think, because if we just random shuffle one, yeah, there's gonna be like, we don't care. What the fuck is this? Why is it this broken? Why are these broken? What is happening? Okay. Nice. I think that's what we need. I just want to do like a quick check if this is correct. It's gonna be the first time I even try to render the debugger, but so here just do a random uniform distribution. Yeah, you have it there. Yeah, because I want the trend. No, test it. The test set is just a random translation, basically, just random numbers. not uniform. I said fucking random. Uh, what is the random function here? I don't want uniform. I don't want uniform distribution here. I just want like random. Oh, random. Okay. Cool. Random, yes. But yeah, I feel, and I'm not the only one actually, but many people are feeling that they are losing a lot of IQ points in programming, but I can agree on that. Is that it is kinda I mean yeah. No, no, my thesis. Why do you want to see my thesis? Let me just see if this works. Of course it won't. No, why is it -3? But why? And then shit, I'm very hungry already. We'll go and grab something. What do I have? I want it to be -1. Like, there are people that say, and wait, I'm recording. Can I also record? Yes. Oh shit. So there are people that are saying that okay, software engineering is like dying out. Like many people are saying, okay, yeah, diffusion improved a lot. Like what the fuck, all these agents-based things are like only at the beginning, and I agree on this. I agree on this, but I don't feel. I mean, software engineering itself will change a lot, but I don't think there will be the need of less engineering or less engineers or less software engineers, but rather everyone would. I mean, the people that are gonna go through this, they will come out on the other side with just work in more abstract way and like have a more managerial role. And on one side, and on the other side, you will be kind of paired. What the fuck is it? What is this? We just started on it. Okay. On the other side, we will also go like lower level and understand more, and like all software engineers and even programmers or whatever, like compiler engineers, all these people will have access to what I think more um, like more tools to understand and make better code and do way much more interesting things in a even higher level of abstraction sometimes. Like I'm writing most of some of the code here. I know what I want. I know where I want to go, but you still need to understand what's going on. Um, and at some point, like maybe these agents would write the code, write the tests, and that's fine, as long as you have like a small understanding of what's going on under, and you have some rules that are enforced. For example, the training and test set. Like you cannot merge them, and these LLMs don't know about it yet. I agree, but what I'm feeling now, for me, for example, is like, okay, if I had to spend like maybe 2 3 days to define like different custom, I don't know, encoder, multi-layers, blah blah blah, whatever, what I feel in the future is gonna happen and is already happening. I would just say, okay, I have, yeah, idea 1 2 3 4 5. Can you try them with like the code base that I have already, that I know is not cheating, is not doing anything, like with a set of tests and whatever. And the LLM will start writing everything, blah blah blah, run it and see it if it works or not. And then I see, okay, maybe I thought this was better, and then I go into the code and ask the LLM, oh, why did you do this? Why did you do that? And as of now, like, they cannot do that. They cannot explain why they did that or why they didn't. But for example, like this thing about the hurt or whatever, these points in a circle, I'm sure if I just said like, okay, I want to have like uniform distribution, okay, you would get something like this. But I'm sure I would never have gotten something like this without a proper maybe explanation. Maybe I should ask. But what I'm saying is we will have more agency with these tools, and I don't think software engineering will be that, but rather it would enter a new phase, a new stage, a stage where you have way more agency, where agency is way more important because you have a lot of leverage, and leverage is like someone else is the right code that is not a person. And I think that's gonna enable like very cool things. And yeah, of course, the responsibility is gonna be higher because I mean you need to be careful on what they do, and that everything goes well. But sometimes the thing that I'm worried is sometimes what they do works, and they are very good at doing that, but it's difficult to understand why they did it. And at least to me, I'm not comfortable to have code that is written by someone else that I don't understand. Even with people, like if you write a code, you explain me why you did that, and I need to understand exactly why you used that data structure, why you did that, and so on and so forth, and what was the like logical step to go there. But otherwise, it's very difficult for me to say, okay, I'm gonna ship this code, which is something that is happening quite a lot. And I saw this. Um, Let me see if I can find it. This tweet from Levelsio, which I really like as a person and as he does thing, and he's really pushing forward, which I like as thing. But I feel like, just give me 1 second and I will find it. And of course, this guy is tweeting so much every day. So it's very difficult. Yes, this one. And I mean, I agree on this. I will link this in the video. But I agree on this. But at the same time, like software is not just one image. Like software has consequences. Like it has real impact, right? And it can change things. It can can do stuff, right? So as long as it is like an image that is there, it doesn't do much, it's alright. But and of course you can even argue that images do things. But what I'm saying is, you know, software is a little bit more complicated than an image. But I'm sure we will eventually go there, and I'm not denying that, and I'm preparing for that. This is why I'm trying to do this vibe coding and stuff like that. So I'm not denying, but I'm just saying that I feel this uh, connection, this similitude is a little bit too much. Yeah.
Hello. Hello.
Yo. So yeah. Shout out to this guy. Okay, guys, I need to. How? Yeah, I'm coming. I will just stop my screen and everything. I just need to go to pick up my laundry. I'm back. Perfect. Oh shit. What is this guy doing? Hmm. I think it was good. Hmm. Another thing I wanted to try is the Muon optimizer. Like everyone is saying that it's very good. I wasn't able to make it start yesterday, but should be a very good. So, bad side epoch. For epoch range, okay. Validation if equal plus 1% 5. But why doesn't he do like a badge thing here? I don't understand this. Maybe it's just for training. Okay. Cloud. What the fuck is it? What the fuck has been cooking here? But I don't need that. And not even cloud. No. The fuck. Era riconosciuto. Malos. I mean, it's smart. About 3.5 is smart.
good at doing the rendering, but they're still like the largest commercial.
Why not? Because we're not using thesis, are we? Exactly. Oh, hello, who's the third? Oh, un saluto al Simo, certo. Buongiorno. Che si dice? Ah, non sai. Ma perché? Yes, we don't have touch function. And then linear. Emma. Ah, okay, yes, there you go. But, right. Hehe. Adam and W, Lambda. I could try. That's not the first though. Let's go to the mini tutorial. Okay, so basically what they do is these. Taurelo. And you can do this. But do we have 10H? 10H, yes we do. Amazing, Georgiot. Thank you. This should go. Python debugger, yeah, let's go. Dot base and code. But there is a init. Why there is no, it's not working. Bro, and they're gonna take away the numpy as well. Oh wow, it's gonna be like amazing. Amazing. Because I need to. True. But yeah, I was starting from American code. Training is What you mean? But guys, you don't understand how cool it is, I think, to just basically. Oh, so I shouldn't even need it. Be able to run things on the MacBook, like, okay, like these small things. It's fine. I feel like the future of coding, neural networks at least. Ooh. Yeah, the future of writing neural networks is gonna be like you have your like tiny test data set, like not test, but like with some images, like you have the data loader and everything on like your MacBook. Okay, so it's maybe even like 5 GB or something, right? So you write your code in TinyGrad, you write it on your fucking MacBook, and then it works. Then it's fast. Data loader is fast. You have not many images. Um, if the data is the same, so you don't have like bugs in the data further down the line, you should just use your MacBook to work. Maybe you get a good MacBook, I don't know. And then you have the same code base on whatever GPU you have, like here, there, and then you just deploy that to whatever GPU and compute you have, or even like with the idea of George out having like a distributed petaflops that you can just rent instead of hour and stuff like that. And so I see this the only way to streamline the work, like let's say. And why it's gonna be like pain in the ass every time you have CUDA, blah blah blah. No, if you have just TinyGrad, bro, like you. Okay. Basically, you can streamline everything to whatever GPU the fuck you have, and maybe you can even find like when there's a search, you can even find a GPU that suits most your. Hey, come on, will you stop there? Why not? Like in the end, like these are just this is the same thing over and over again. Why 1999? What the fuck is wrong with that? Ooh, shoot. Yeah, I cannot concatenate. No, I should be able to. I just concatenate in the other direction. Yeah, but the dimension doesn't match. Why don't you match? And wow, I mean it's super fast. I mean okay there is no data loader but 6,000. Why you training this is are less than how? What? Why the hell are like 99,000? And why is it number sample that? I hope you're right. But it makes sense that it shouldn't be invalid if I don't know why it was left. Yes, that should be it. 9,000 actually. Yep. Yep. True. Nice. But I think then it would be broken again here. Because we have very good error there. See, like, as I was saying, it's very difficult for LLM to get everything straight, and you should have some kind of knowledge of what it's doing, otherwise, yeah. Security tester would have a good life. And to be honest, there was an hacker that, yes, that was able to get into the server of level 0 game. I don't even know how, but just to show that, yeah, these things are easy to do. Because LLMs are not that smart yet, so you need to be careful when using them, of course. Nice, so we now have our dataset, right? We have the shape, and we have validation data, the shape, and also test set. Test that. Nice. And of course we're writing in tinygrad. That means that Cloud probably doesn't know shit. In fact, this is optimizer. How it should be done. Not this way. But yeah, I think that should be the best way to do stuff. You know what this is. And this code is already fucking bloated. But we need to. Why am I defining the model? What is it defining the model? Is the encoder. Alright. I think we should be around here at some point. See if it goes through. It goes through. But I think we need to do model accuracy. And of course, we need to write tensor in the training, otherwise it will not work. Yeah. So let's restart. I don't know if I need to define the step function. Wait, what? What is wrong there? Table is not supported in math. Shit. Why do I need to call it numpy? Shit. should do. Yeah, understood. I guess this should be the type before that's it. Exactly. Like we want flow 32 and X badge. Yeah, I understand. So yeah, it's good. Should work. It doesn't, of course. Why am I listening to that? Mm, mm, mm. I think it's different. Class D types. Why do I import it? Dulce de leche. Thank you, Alvaro. Why is it done? I'm going fine. Of course, I don't understand. The types. Makes sense. Now everything is colored I like. Like, it should work, right? And why is it? Why is it so slow? No. Church. Hello. But I don't understand what happened. I don't know what happened. But okay, wait, I'll do, you know, a little less number of sample. What is number of sample? What is it that parameters? What? Come on, I don't know how to. Yeah, the CPU is not doing much. So what are you doing? Why are you taking this long? Let's put some music. None. Why none? Oh, fucking Array none. Oh shit, in the data loader, what the heck? It's a data problem. Make more sense. Generate data set. I think it's in the train containers. I guess if there was a race. I guess if there was any race going on for like chip dominance, I feel like Europe is losing the dominance to China now. And they're quite impressive, I think. Yeah, so why the heck? There is an an, but why there is an an? I feel and it's only the first. So how is it? Oh shit. How to are we sure this bit about this formula? Even. Okay, fair. I wanted to and oh shit. This should work now, I guess, but no. This is the only bad thing of using the debugger in that way. Let's see. We shouldn't have any nans now. That's perfect. Yes, yes, I think it was that kind of a problem. So let's go. The only thing is I don't really like is that basically everything is computed lazily. So whenever, like, nothing happens until you want to kind of optimize or like do numpy basically. That's when the whole graph is realized. Why is it again? No, I don't like this. Why is it like that? Amazing, this guy. Sì, dai, mettici quanto vuoi. Tanto chi se ne frega. Eh, what is wrong now? What is wrong? The loss is correct. All the data are correct. So, what is that you don't like? He doesn't like the optimizer step. Why not? Do we have a step? Maybe we don't even have a step. 0 grad loss. Yes. Optimum step. Però se non va io non so cosa fare però cioè. Exception, no description. Cool. Judge 16 months ago, there's not any changes. Why? You know what I want to try to do? Let's see if this can help us, but I don't think so, yeah. That's the only thing that is different. There is no functional thing. Why will you still write that? Really, that wasn't it? See, it doesn't make sense with this. Bullshit. Where? We're back at that. 94 minutes. I have honestly no idea why. Let's see. Oh, I think because we didn't implement it the right way. I don't know if you would call it forward as well. Oh, for fuck's sake. Could have been this. But it's not. I have no idea what's going on anymore. Still the same problem. That was my laundry. Okay, wait. Maybe we need. Why is this? Oh, I don't understand what. So basically, these gives me what? Oh, why? Ah, because Layer 1 bias, layer 2 bias. Yes. 52. Why are all odd? I have no idea what it is. Cool. I don't know who's watching, probably. I hope you enjoyed. I will just stop now. I need to get my laundry and I need to think about this problem. I have no idea what's going on. So, have a good one. Thank you for watching.